Hello, everyone. It looks like we're going to get started. My name is Jason Boobles, and I'm a security consultant with Isec Partners, a division of NCC Group. We're here today to talk a bit about VPC configuration, access control strategies, and how to audit your policies to make sure you're delivering a least privilege configuration. So you guys are a pretty different audience for me. Normally, I'm talking to people who love to break software and are probably running some sort of femtocell in the audience to steal my cell phone. And so it's kind of nice to not have to worry about that. So Isec Partners is an application security testing firm, and we are increasingly seeing customers come to us to test their applications who also want us to look at the platform they're delivering on, AWS. And so a couple of years ago, I did my first AWS configuration review. And like any good pen tester, I went off and madly read a bunch of documentation a few days before the engagement to learn all the cool things about how to secure AWS. I arrived at the customer and found out basically they had some EC2 Classic instances that were running in a single security group open to the world, and they gave me root credentials to do my audit. And so we have started to sort of coalesce and standardize on what an AWS configuration review is. So if we're going to review your configuration, what are we looking for? We're going to first start off with IAM best practices. Are you managing your user accounts correctly within the cloud? And then we're going to start looking at your network access. Security groups and network Hackles, obviously, but also if you're using subnets and any type of gateways to try and do isolation, we'll review that configuration too. If you're using other AWS services, we'll dive into those and make sure that their security configurations match what standard documentation and just normal intelligence should be. And then we're also going to look at your logging policies. So we see the same thing over and over again. The first thing that we see is a customer puts their instances in the wrong security container, the wrong subnet, the wrong security group. And those groups have very permissive Hackles. So they're open to the internet, they're not engaged at all. If a customer is deploying into multiple regions, frequently those regions are mismatched. They may have done a great job securing one region, but the next region they delivered into is just default wide open. Nobody's looked at it yet, except the two regions are talking to each other. And then also poorly managed administrative interfaces. Lots of customers try to do bastion hosts to protect SSH or RDP, except while they do that design, they still leave it open to all of their hosts within the VPC. At the application level, the most common thing we see is leaked secret material. Your access keys, your crypto keys, things that you don't want an attacker to have are sitting out there in a bucket, in your source code, in configuration, and we can get to them very easily. That's usually helped by the fact that most customers grant way too much access to their users. And they assign admin level rights to automated processes like DevOps processes. If you're deploying test or stage into the same VPC as production, which frequently happens, many customers don't think about the differing security levels that are necessary for those two different systems. And finally, if you're deploying on AWS at this point and you have not enabled CloudTrail, go home and do that now, because when you have an incident response, you'll be incredibly happy that you did. So we're going to talk a little bit about what least privilege is from the pen tester perspective, and then dive into trying to define a virtual cloud that's going to meet our requirements. Along the way, we'll talk about what we would audit if we were to come in and look at this. And then finally, we'll talk about a few different strategies and tools you can use to do this type of thing on your own. So we could go into a theoretical definition of what least privilege is, but I don't think it serves us well. So we're going to use just a working definition. The goal is to give enough access to your actors, your users, your computers, so that they can do the job that they need to do, but no more than that. And the reason we're trying to do this is if one of those ever gets compromised, you want to limit the potential downside. So going back to our common mistakes, let's just go over a few of them. So consider the idea of misplaced EC2 instances. You've gone off and you've done a tremendous amount of work to create 2 different security groups which are going to give web service to the internet while still protecting SSH and limiting it to your own corporate network. Except if you go in and look at what the configuration is, you find out the reason it's been working this whole time is they're sitting in a default group which is just open to the internet. And so from a least privilege perspective, all users now have access to your administrative interfaces. And if we're talking about leaking credentials, a really common pattern is you've got some DevOps processes that are pushing code to your VPC and doing configuration of your instances, and you're not quite sure what that code needs in order to do its job. And so you give it a tremendous amount of access. And you put the AWS keys into some sort of data bag off in an S3 bucket. But now all of your users have full read access to S3, to all of your buckets. And so one of those accounts gets compromised because they have so much access to S3 that they don't need. All of a sudden, an attacker gets full IAM rights to your system and can write whatever policy they want. So a couple of things for people who haven't done a lot with VPC yet. If you've worked in EC2 Classic, one of the big things that VPC is going to give you from an access controls perspective is it gives you the ability to segment and isolate your instances. You can have instances that only listen within a private network, not on the internet, and then you can control access between subnets, sort of like you would from within a traditional corporate network, except that it gives you a powerful platform for building applications. And so we're going to ground this in a theoretical company. And since I'm from Seattle, the company's goal is to create an online menu planner for those dinner parties where all of your friends have competing food allergies. So it's a typical company. We have some groups that have no business accessing AWS config, like your management team, your sales team. But then we have a couple of different groups who are all in operations and engineering, and all have differing needs when it comes to actually touching your AWS configuration. The architecture is going to be pretty straightforward. We've got a web UI, which is going to be backed by a service-oriented tier so that you can easily expand out. And then that's backed by a MySQL database because, hey, we want to manage our data ourselves. We also have an analytics team that wants to do some data mining on this on the collected information. And so we have a standard ETL chain, which is going to get rid of some confidential information, change up the schema, and drop it into a new host that the BI team can run tools against. We're also going to use 3 different AWS services. We're going to use S3 to store our configuration data, and also some temporary data storage for the application layer. We're going to build session management on top of DynamoDB because we can pull a library for that for free. And then we're also working on a mobile app. So we've got 2 different topics that we want to push with SNS from the app layer. So the first thing we need to do is figure out how do we want to build our network. And so if we're trying to apply least privilege at the network layer, we need to be able to classify our different components, understand how do we need to access them, who needs to talk to one another, and what classification of data are these components going to work on. And so we have tools like our subnets, network Hackles. We have differing types of gateways that we can build. And we can even use things like NAT and elastic load balancing to try and isolate access from the outside. So first, let's go back to Monkey Buffer and try and classify our components. So the admin jump host is pretty easy. It sits off in a bucket all by itself. It needs to be accessible from the internet, but maybe not from the general internet. We have this data warehouse that needs to be accessible from the business intelligence team, and it has a different level of data than the actual data layer. So the ETL host is actually going to have that customer PII, but we don't want to put that into the data warehouse. So we're going to separate those components off, but it seems reasonable to put the ETL host with the data layer since it has full access to the schema anyways. We also have, say, the web front end and the application layer. We could separate those, But we're also thinking later that we want to expose the web service tier to the mobile application. And so maybe it makes sense, since they operate on the same level of data, to put them in the same bucket in the network. So as a sample, we come up with this kind of network diagram. We've decided to go with 4 subnets, and we're hiding our web front end and app layer by exposing ELB to the public internet, but then using that to route traffic into a private subnet in our VPC. We also need to be able to give the 2 web layers access to Amazon, but we can do that by routing them through a NAT that's in our public gateway, rather than putting them directly on the internet themselves. The admin host has to be on the internet, and so we put that in the public subnet. And then we've also created a subnet for the data warehouse. Instead of giving that direct internet gateway access, we use the VPN connection, which is going to connect back to our business. And that way, the BI team can get to it, but we don't have to worry about it being hit from other people. So when we're trying to build the least privileged network, make sure you're using your network Hackles. So they're a stateless firewall, and you do have to open up the large ephemeral port range in both directions. But network Hackles give you a way to protect low-order ports, and also to sort of cherry-pick ports up in that big open bucket if you're getting hit by a denial-of-service attack, if you've got some specific RPC listeners that you don't want to be accessible on the internet. Network Hackles can help you do that, and they're an important tool for defense in depth, which generally what we see is the default rules, which are pictured on the bottom. So, okay. You're going to go through and you're going to look at your own network configuration. What are we looking for? Again, the first thing we're looking for is, are you deployed into the regions that you expect to be deployed in? And do those regions match as much as makes sense? Obviously, for some applications, your regions are going to have different configurations because you're delivering different services. But are they delivering the same security policy that you're trying to deliver across the globe? Do your different network technologies meet your intended design? And do you have your network Hackles in place? And finally, if you're hosting parallel infrastructure within your VPC, have you thought through what the different levels of access are going to mean? And can I get in through a test system and pop your production network? So after we've built a network, we need to start deploying EC2 instances. And we need to think about least privilege for those. So when we're going through and decomposing our EC2 instances, we need to think about what components of your application run on them and how are those supposed to communicate. Additionally, we need to think about how they're going to access AWS services as well. So we've talked about network isolation techniques, and obviously there are application-specific techniques that you're going to employ. But within VPC, we have security groups and we have IAM roles. So just a quick refresher, security groups are a stateful firewall, but one of their more interesting properties is that every instance can have up to 5. And if you read the documentation, this is done so that you can have a tremendous number of network rules for each network or for each of your EC2 instances. But the rules between them add permissively. There are no deny rules in security groups. And so if one rule gives you a little bit of access and another rule gives you full access, the result of composing them together is full access. So the typical security group configuration that we see lumps everything into 1 or 2 security groups. So if we look at Monkey Buffer, we could actually pull this off. It's a fairly simple application. And let's say that we were running SSH on everything but the admin jump host on some off port. We could actually compose all of the access together. But while this is easy to copy between your regions, it's incredibly brittle because all of a sudden you get a new requirement that comes in. Say you're running a database host on the web front end as well for local storage, and now you can't protect it. So you can improve this a little bit, and sort of the next step that we generally see is a security group per role within the network. And so, again, this is relatively easy to copy. And it also allows you to use your security groups as source and destination within your rules. But it becomes really difficult to understand why 6 months down the road, because you have a group that has a tremendous number of rules in it. Now all of a sudden you need to make a change. You've changed services that are running on those boxes. And so you have to dig through a whole list of rules to understand, why was this one put here, and if I change it, what will I break? So we could actually use that 5 groups per instance as a role-based access control model as well. And if we think through the web front-end role, what does it do? It does 4 different things. It listens for HTTP connections. It talks to the application layer. It is a client to AWS services. And it's a client for administrative commands. So by doing this, you're encoding the design of your access control model in the security groups that you've created. And those are hopefully appropriately named. So you can go through and understand what it is that a web front-end role is supposed to be doing and why that access is assigned to it. So if we think through all of our different applications, we can see that, at least in this model, for a simple application, it works fairly nicely because each one has 5 or fewer roles, which can combine together. And in the case of admin listener and admin client, we can actually use those as the source and destination for the security group rules. And we know that any host which is put in the admin jump hosts group is going to be able to access port 22 on any other host in the system. But hopefully, no other rule within the other groups gives that right. So I also said we had to think through what we're going to use from AWS, because with IAM roles, we can actually give credentials to access these services. And so if we look, it's pretty obvious that 4 of our application components have no need to access AWS. So we can decide with the security groups before that, hey, we don't need to put it in that group. But we can also start to look at the fact that we need 2 different IAM roles to build out this application. Web front end and application layer both read from the configuration bucket, but that's the only thing they have in common. And so one thing that's important to know is that you can only assign your IAM role when you create your EC2 instance. You can change your policies at any point, but the role is basically static once it's assigned. And so we know we have to have 2 different roles because we have 2 different actors within the network. So why would you want to do this? One of the great things about it, if you can pull it off, is that your long-term credentials tend to have a tremendously large amount of access because when you created them, you made the policies to do a bunch of different things. And so if I'm able to get credentials for a really big long-term set of credentials, a long-term policy, I probably have a lot more access than you want me to have. And you're going to leak these at some point, right? AWS does a great job of trying to help you protect them, but they get leaked in almost every test that we've ever been on. You can find them somewhere, usually in source or in a configuration bucket that's open to everyone. The other great thing about instance credentials is they change over time. And so if somebody happens to get them, they're only good for an hour. So, okay, going back to auditing, what are we looking for? Do your groups and assignments of roles match across your regions? And if you have role assignments, what are the policies that are assigned to those roles? How much access are you giving each of your instances? Also, overall, do your security groups meet the intended design? So there are a bunch of different ways that you could do this. And from our perspective, the goal is to make sure that the intended design is met without giving more access than you actually want. So you've created a network, you've created some instances, and then the meat of the problem is how do you deal with user access and what kind of policies do you actually write for these things? So IAM gives you the ability to write policies and apply them to both users and EC2 instances. But you need to understand, what are your users going to do? What tasks do they actually have to perform in order to do their work? And then from the EC2 instance perspective, what services are they going to be talking to and why? So we need to define what our roles and tasks are. And so we started off with an org chart for monkeybuffer.org that had a bunch of large groups. So we had a support group, but if you start to think about your different groups, your engineering team, your support team, everybody does very different things. And so if you decompose the support group, you might think, okay, corporate help desk maybe falls under that group. They have no business accessing your EC2 configuration. But maybe the tier 1 product support group needs to be able to understand whether instances are currently running, what regions are functional at this point, and perhaps they need to dig into a bit of log file to answer customer questions. Then another role that's been around in every company that I've ever been a part of is the impossible problem solver. The person who's not necessarily on the engineering team, but is the one that takes all of the really hard problems and does a tremendous amount of debugging before they hand it off, or in conjunction with your engineering team, to make sure those problems get solved. And so between tier 1 product support and the impossible problem solver, we obviously have a very different level of access that's going to be needed in order to do this third job. So we need to define policies that enable tasks. So from a task, I mean some activity, some workflow that a person has to go off and do in order to run your system. So if you're thinking about an operations person, perhaps that operations person needs to be able to start and stop EC2 instances and assign a role when they do that. Maybe a support person has to be able to go into the debug output bucket in S3 and pull down log files in order to delve into a problem. Both of those people definitely don't need to be able to read the configuration bucket, but maybe the impossible problem solver does. So we can't really talk about an application, but we can talk about a few different tips. The first of which is, very few people in your organization actually need access to IAM. And the reason that I'll bring this one up is that IAM is sort of the nuclear bucket, right? It's root. If you can get in and change IAM configuration, you can give yourself escalation of privilege and take over anything else within the system. Also, any policy that gives access to service : as an action is questionable, because does somebody, if you dig into the actual actions that you can use for every service, there are a ton of different ones, and a task usually doesn't require all of them. So the ones that are administrative facing, you probably want to filter those out from everybody but a handful of people. You definitely don't want to grant access to anything your product doesn't use, because in this case, we're using 4 to 5, maybe 6 different services, but we're not using CloudFormation or Elastic Cache. So nobody except the root admin account should be able to affect those systems. And anything that has a secret in it, limit the access to that resource. You should be limiting access to resources in general when you write your policies, but if you're storing AWS access IDs, if you're storing crypto keys and passwords, nobody but the very specific set of users who need that should have access. So you can also use conditions to enforce this. And this can get rather confusing, and you can end up putting yourself into a tough place by overusing conditions. But there are 4 that are really kind of interesting. You shouldn't have anyone accessing your APIs without using HTTPS at this point. So you can actually write all of your policies to say, this can only be done if the user is using HTTPS. Also, multi-factor auth age, when compared against null, says not how long has it been since you did the MFA check, but did you do one at all? And so you can use this to say, for these specific sets of commands, or maybe all of them, you can't do this unless you've used MFA to get your session. Current time is interesting because it allows that temporary escalation of privilege. Maybe I need to give someone privilege to do something really powerful, but they only need it for a week. And maybe I'll forget about removing the policy, but if I set a current time that only gives them a week, then hey, it expired anyways. And also, source IP, you can use that to limit commands to come from your corporate network. So they can be pretty helpful in assigning least privilege. So now we have to write policies that enable tasks, but we also have to put them on our principals. So we're talking about users, we're talking about EC2 instances as principals. And so we can assign those directly to users, or we can do it indirectly through groups and roles. So you can assign policies directly to users, but when you're going through to audit, it becomes really difficult to understand that a user has policies specifically assigned to them. You have to ask for those in a different way, and then you have to reconcile them against group and role assignments to figure out what a user really has. Because again, these things add permissively. So if you give someone direct user assignment to do something very powerful, but you don't generally do that, you're probably going to forget about it at some point and not realize that there's an account with so much power that's sitting out there. So overall, we need to sort of create an assignment strategy and stick to it so that when we go back through an audit, we know what it is we're looking for, and we know what should not be there. So let's think through some strategies. If we start to break down our monkey buffer groups, we can see that we've come up with, say, a support group, a business intelligence group, ops, and then an engineering team. And so we're going to create a group per role that tries to satisfy everything that the users need to do. And so if we just look at engineering, they're going to need to work with the services that the product uses. And so we've given them an action of : on all resources to let them do their job. So this becomes really simple to audit because it's really easy to look in and understand that Joe is a member of the engineering group, and therefore they have these rights. And for small user populations and easy workflows, it's easy to maintain. But the problem becomes that exceptions are really difficult to implement. You're going to have to break your access control model in order to put an exception in place. And if you don't, what you generally end up with is a degeneration to everyone as an admin, because at some point, some engineering user is going to need to create a new EC2 service. So maybe they didn't have that at the start, but you change the engineering policy so that that person can do their job. And then maybe they need to create a new service user. So all of a sudden, they have access to IAM where they didn't before. And scope creep creeps your permissions as well. So we could also look at another strategy, which is pretty popular, which is to use a group per type of access that you need, and use composition to give a user give the user the access that they want. So this mirrors the security group policy we talked about before. Role-based access control composed of a bunch of small different grants. And it's incredibly flexible. But over time, it breaks down as well. Because all of a sudden, you find out that you have some group that gives X amount of access, but now you need a little more or a little less for one user. So what do? You could increase the access of the one group and just assign the user to that. You could create some vestigial group that now the one user is a member of both of them, but you have group explosion. Or you could start to reduce access for everyone else if it's a reduction in access, and you're just breaking your own model. The other problem about this is that it's focused on an individual user. It's not focused on a role, and it's not focused on a specific task that needs to be done. So before we go on, let's talk a little bit about STS. So hopefully you've all had some exposure to what STS can do. So STS gives you temporary credentials. They give you a session which you can use to access AWS APIs. And the credentials are ephemeral. By default, they're only available, or they're only valid for an hour. But using getSessionToken, you can get a token only available for an hour, which has the exact same rights that you would have normally. So it's great for multi-factor authentication, because if I need to run a bunch of commands over the course of an hour, and I don't want to sit there and type my MFA token in all the time, I just get a new session for an hour, and the fact that I used MFA is carried through for conditions. So you can use STS to create a really powerful least privilege tool, because you can focus everything based on roles or task workflows that have to happen. So if you think about it, using assume role, what you can say is this user, using some sort of credentials, and the name of the role, can get a temporary session which allows them to execute whatever workflow needs to get done. And that role can be tailored very specifically to the type of work that has to happen. And so a user can be allowed to assume, say, 100 different roles. You can do it that way. And everything can be very specific to the task. So one other benefit of this approach, hopefully you guys attended the Delegation and Federation talks yesterday, but if not, I'd recommend you go through and look at them, because you can use that assume role with SAML, with web identity, to carry a user's authentication context from the corporate LDAP that you already have maintained. And so instead of having a ton of different users who are configured in IAM and trying to figure out how to manage those accounts in addition to managing the structure that you've already got managed, you can just carry that through and create some sort of way that a user can go off and get a role for the very specific tasks that they're supposed to do. So it's great, because if you already have a complex LDAP topology where people are in the groups associated with the functions that they have at work, then as they move around in that LDAP, they gain and lose access appropriately. So access rights are tied to a task or principal in this kind of model. And it's really easy to grant temporary escalation of privilege, because you can take any user that you have and assign them a policy that says, for the next week, they are allowed to assume this role that they normally wouldn't be able to have. It can also reduce the access keys that you have in configuration files, as long as your services can use these temporary credentials through EC2 roles to access the services they need, such as S3 and DynamoDB. And like I just said, if you can use federation effectively, you can limit the total number of accounts you need to manage in AWS, which makes overall auditing of your configuration much easier. So the cons to this are a lot of DevOps tools at this point can't yet use EC2 roles. Roles are fairly new, and so it's not possible. So you're going to end up having to use keys with those products. It also separates your access assignment from your access, or your definition of access rights. And so if you have a tremendously large population, it can make it really difficult to audit. Finally, for AWS people, when you have a group that gives access, usually there's one policy that is granting the access you need. But with a role, if 5 roles need to do roughly the same thing, you have to have a policy per role. And when you go in and you need to tweak that role because some requirement changed or you figured out that it was too much, you have to change it in 5 different places, and remember that. So right now, it can be a little difficult to deal with this because policies can only be written for a role at this point, and you can't really share the policy definition between multiple roles. So obviously, there's not a best strategy in this, and I'm not trying to push one over the other because every company is very different, even though we solve the same problem. But groups are great when you need to assign administrative rights. You need to create users that can actually do administrative work, right? So you can create a group for that. They're also really great for role assignment because if you have a bunch of EC2 users or a bunch of IAM users defined, then you need some way at least to grant them assume role and a set of roles that they can assume. And so you can create groups that grant that power. Roles are best for actually granting the rights necessary to do work. And of course, you have to use roles for EC2 instances. So let's think a little bit about how we would go about this for Monkey Buffer. So just for the web front-end role, what does it do? We know that it uses the application layer, but that's not something that AWS is going to be able to solve for us. We have to solve that outside. But we can actually use a role to solve both the S3 access and the DynamoDB sessions table access. So we create a role, and we need to write a policy. And in this case, since it's the web front end, we know it only needs to be able to read object or get object read from the configuration folder in Monkey Buffer files. This would also need to have the DynamoDB access as well. And we might also give the role the ability to list bucket so that they can go through and find out what's in there to read. And then we have to actually create an access policy on the bucket, which is going to let this role work. So we go through and we create list bucket and get object for the configuration folder, and then we can define the principals as our 2 roles that need to have this power. Finally, because this is assigned to an EC2 instance, someone probably in ops, needs to have the run instances permission to EC2 and the ability to pass the web front-end instance to those instances as they start up. Okay, so we've talked through creating policies for least access or for least privilege. What are we going to look for when we come through an audit? So the first is IAM best practices. You need to make sure that you're treating your AWS accounts in the same manner that you should be treating your corporate accounts as well. We're also going to make sure that CloudTrail logging is enabled. As I said before, when you go through an incident response, you will be incredibly happy that you have your CloudTrail logs enabled, because otherwise we're not going to be able to find anything. So the next thing we're going to look at is whether your access policies are minimal and whether they're matching your requirements. And so this is a very different exercise for every application. But the first thing to start looking for is who has the star action on which resources. We're going to dig through all of your configuration files and your S3 buckets looking for AWS access keys, because chances are they exist out there. And then finally, if you're using AWS services, each one of them has a slightly different set of rules you need to look through, but you need to audit each one individually. So we've talked about how or what to look for. Now, how do you do it? So the goal is literally to ensure your implementation matches the design that you intend, because you're trying to limit the damage from one flaw and make sure that you can't chain that to another series of flaws and get total system compromise. And so you're trying to verify your security goals. And more importantly, you're trying to make people like me sad. So how do you do it? It's pretty easy, right? You can use the AWS provided tools you've got. You can go into the web console and find out every piece of configuration data that you want. You can also use the command line client to pull down all of the JSON blobs and then kind of link them together and understand how they fit together, which is actually a great exercise. If you haven't gone through and figured out what the response to each one of those little API questions is and how they link to others, it's really important that you understand that. And again, you can write your own custom tools either through the command line client or using the various APIs that are going to get you the same information. There are long-term monitoring tools out there. There are a bunch of vendors out on the floor who probably have things that you can use. And you can also use things like, or some open source tools like the Netflix security tools, which will go through and actually monitor long-term and watch for changes in your configuration. And then another tool which is available for free, which we use, is something called AWS Scout 2. And you can pull it off of GitHub. And when you see it, you'll notice that it's actually a security testers tool, which means it produces an incredibly large report that you have to figure out how to understand yourself. So that's why we're not doing a demo, because it would take forever just to parse through the pretty HTML page that gets put out. So how do you start? If you already have a VPC configuration built, then obviously it's difficult to change. But you should start with the basics and just make sure that you're following IAM best practices, that you have CloudTrail logging in place, that you're consistent across your regions, and that you don't have glaring mistakes like star-on-star kinds of policies. From there, it depends, right? There's always going to be a trade-off between the ability to manage a deployment and keep it running, and also having strict security design. And so for each organization, that's going to be different. But the goal is always to have the least amount of privilege granted to every person in the system, because when that account gets lost, you want to limit the damage and the amount of pivoting that an attacker can do off of that account. So I would strongly encourage all of you to go off and do this as your own regular practice, and make sure that it's happening on every couple weeks, once a month. Make sure that you're watching frequently recording your results, and looking at your differences. Because once you're starting to do that, you can actually look at changes and ask, why did this happen? And push back against the change to understand if it can be narrowed in scope at all. So, thank you very much. And if anyone has questions, we can do them out in the hall.